Hi friends, welcome back to ElectrAspirant, an assistance to electrical students for objective type exam preparation. It is an initiative of Department of Electrical and Electronics Engineering, Christ College of Engineering, Irnyalakuda. In this video, we are going to discuss questions 1 to 25 of Electrician-Agriculture of Kerala PSC examination, and the question paper code is 152 bar 2016. The cutoff was 59 marks. Let us start discussing the questions. Let's start with question number 1. Repulsion motor is provided with. The answer for question number 1 is option A, commutator. So, the repulsion motor is a single phase AC motor and it works on the principle of repulsion. And in the case of a repulsion motor, the rotor is similar to that of a DC motor. So, we know that for a DC motor, a commutator is there. So, the answer for this question is option A, that is commutator. Let's go to the next question, question number 2. Whenever a polyphase motor is loaded, the answer for this question is option number B. Induced EMF in the rotor increases and the frequency will be rising. Let's go into the question number 3. For 3 resistances which are connected in 3 phase, the power consumed will be more. In the case of, answer for this question is option C, that is delta. So, if 3 resistors are connected in 3 phase, then the power consumed will be greater for delta connection than a star connection. And if the 3 resistances are equal, if all the 3 resistances are identical, then we can study some relations. In the delta value of resistance will be 3 times the star resistance. Okay. Similarly, the delta power will be 3 times the star power. Similarly, the delta torque value will be also the star torque value into 3 times, and the current is also having the same relation. So, this is the relation for the delta connection and the star connections if the 3 resistances are equal. But here they have not mentioned anything like that. So, the power consumed will be more for a delta connected system. So, the answer for question number 3 is option C. Let's go into next question, question number 4. Synchronous motors run on leading power factor when connected in. The answer for this question is when connected in overexcited, and during this it works as a condenser, and this is known as the synchronous motors which are operated in overexcitation. They will be giving the leading power factor condition. So, the answer for question number 4 is option D. Let's go into the next question, question number 5. The output voltage of a solar cell is approximately. So, the output voltage of a solar cell is approximately 0.5 to 0.6, and the answer for question number 5 is option B. Let's move on to the next question. Question number 6. Slip rings are generally made of. So, the slip rings are generally made of. Answer for this question is option A, phosphor bronze. And this material is actually harder than the carbon brushes, and this is to ensure that there is no wear for the slip rings. Okay, so it is a harder material. So, that is phosphor bronze. Let's go into the next question, question number 7. The hydrometer reading of a fully charged lead acid battery is. The hydrometer reading, which means it is used for measuring the specific gravity. So, for a fully charged lead acid battery, the value is 1.26, and for a fully discharged lead acid battery, it is 1.11. Okay, so let's move on to the next question, question number 8. In induction motor, percentage slip is maximum at. We know that the relation for slip is equal to S is equal to Ns minus Nr divided by Ns into 100. Percentage slip, if we are mentioning the percentage slip. So, this will be maximum if this value is maximum. That means the difference between the synchronous speed and the rotor speed is maximum. And this occurs when the rotor speed is 0, or we can say it is at the standstill condition. The answer for question number 8 is option C, standstill condition. Let's move on to the next question, question number 9. The economizer is a part of. So, economizer is actually a part of option C, that is thermal power system, power plants. And this in the term, the economizer is actually a feed water heater. It is a water heater. It is mainly used for improving the efficiency of the thermal plants, and this actually increases the efficiency by preheating the water before it goes into the boiler. So, let's move on to the next question, question number 10. The crawling in an induction motor is caused by. We have heard two terms in induction motor, mainly one is crawling and the other one is cogging. So, let's find the answer for 10. Question number 10 answer is option D, harmonics developed in the motor. So the crawling means it is the induction motor has a tendency to run at a very low speed when it is compared with the synchronous speed, and normally it will be running at ns by 7th speed, that means 1 by 7th of its synchronous speed, and this is because of the harmonic fluxes in the air gap, that means the third harmonic, fifth harmonic and seventh harmonic, etc. So that is what is crawling. It is running in a very low speed. What is meant by cogging? It refuses to start during cogging operation. During the cogging phenomenon, actually the motor refuses to start, and this is due to the locking between the rotor slots and the stator slots. Okay, let's move on to the next question. Question number 11. The commutator segments are placed in. The commutator segments are placed in the, we know the answer for this question. It is very easy. Option A, it is placed in the rotor. So the commutator segments mainly used for rectifying either AC to DC, and sometimes in the case of a motor, it converts the AC into DC. Let's move on to the next question, question number 12. Reduction in the capacitance of a capacitance start motor results in. So we know that in a the answer for this question is option B, that is starting torque. So why it is so? The starting torque is actually proportional to the current through that starting winding, that is the capacitor also. So we have to improve this current, then only the torque will be improved. Then this current is actually inversely proportional to the capacitance. We have to know the relation between the current and the capacitive reactance XC. So it is the XC value should be reduced to improve the current. XC value should be reduced means the capacitance value should be increased. Why? Because they are inversely proportional to each other. So for a higher capacitance value only the torque will be improved. So we can say that for improving the torque, the higher capacitors should be used. If we are reducing it, the reverse effect happens. When we are reducing the capacitance value, the starting torque will be also reduced. Let's move on to the next question, question number 13. In an AC circuit, the ratio of kilowatt by kilovolt ampere. So kilowatt by kilovolt ampere means it is actually the ratio between active power and the apparent power. Active power equation is VI cos phi, and divided by the apparent power is VI. So cancelling out this one, the option answer is power factor. The answer for question number 13 is option A. Let's move on to the next question, question number 14. The unit of inductance is. The unit of inductance is, answer is Henry. The answer for question number 14 is option C, Henry. Okay, the other units are very familiar for us. Ohm, resistance. Mho is admittance. Farad is for capacitance. Okay, then next comes the year to year. Next question, question number 15. The year to year resistance of a human body is. So year to year resistance of a human body is 100 ohms. Okay, so for your information, I'll give you some more values. One is for dry skin. For dry skin, the value is 1 into 10 raised to 5 to 6 into 10 raised to 5 ohms. Okay, and for wet skin, it is for a wet skin it is 1000 ohms. Then within the body it is 400 ohms, and year to year is 100 ohms. So these are the details of the resistance in a human body. Okay, let's move on to the next question, question number 16. Centrifugal switches is provided for disconnecting the auxiliary winding in a. Answer for this question is option B, capacitor start motor. We have studied how to draw what is the diagram of a capacitor start motor. There is a capacitor in the starting winding, and this is the main winding, this is the starting winding. Okay, and here there is a switch which is used, a centrifugal switch which is used for disconnecting the starting winding when it reaches 75% of the speed, when the rotor reaches the 75% of its speed. So this centrifugal switch will disconnect the auxiliary winding during the capacitor start motor. But in case of capacitor run motors, this will be absent. It will be permanently connected. So there is no disconnecting of such auxiliary winding. Let's move on to the next question, question number 17. Transformer core is laminated. So lamination is mainly done to reduce the eddy current losses. The answer for question number 17 is B. Option B reduces the eddy current losses. For reducing the hysteresis loss, normally we will be selecting a core such that the hysteresis loop is very thin. And for reducing copper loss, core loss means actually it includes both the eddy current and the hysteresis losses. Let's move on to the next question, question number 18. The difference between synchronous speed and, which type of loss is not common to transformer and rotating machines? The answer for this question is option D, that is windage losses. So this windage losses is due to the air friction between the rotor and the surrounding air. So that is being not common in the case of transformer and rotating machines. Let's move on to the next question, question number 19. The difference between the synchronous speed and the actual speed of an induction motor is called as. So how can we call it as? We know that it is known as slip. Option for answer for question number 19 is option A, slip. Equation for slip is S is equal to Ns minus Nr divided by Ns into 100. So it is actually the difference between the synchronous speed and the actual speed of the induction motor. Let's move on to the next question, question number 20. Three resistances of 30, 15 and 5 ohms are connected in parallel. Their combined resistance will be. So before moving into the directly finding out the answer, first we have to go through the options first. Okay, what are the options? You can see that greater than 30 ohm, between these two values, less than 5 ohm. So when we are connecting different resistors in parallel, we should study that the resistance, the equivalent resistance value will be less than the least resistance which is connected in parallel. Here the least resistance is 5 ohm, so the value will be less than 5 ohm. The answer for question number 20 is option C. So similarly, you can study one more thing also. In a series connection, the value of resistances which are connected in series, the equivalent resistance value will be higher than the highest value which is connected in series. Okay, let's move on to the next question, question number 21. Which of the following acts as a depolarizer in a dry cell? So a dry cell is very common to us, which we use normally for a 1.5 volt source, as a 1.5 volt source. So what is the answer for depolarizer? The answer for question number 21 is option D, manganese dioxide. So let's go through the other things also. Zinc is actually used as the anode here. Okay, then the carbon is mainly used as the cathode. Okay, then electrolyte is ammonium chloride. Okay, so these are the things which are used in a dry cell. Next we are moving into the next question, question number 22. Efficiency of a power transformer is of the order. Answer for this question is option C, 98%. So for a power transformer, the efficiency is near to 100%, whereas when we are considering for a distribution transformer, it is between 50 to 70%. Why? Because in that case we will be considering the all day efficiency. All day efficiency means the power output in kilowatt hour, not power, it becomes actually the energy. So the output energy in kilowatt hour divided by input in kilowatt hour becomes the all day efficiency of a transformer in 24 hours. Okay, both taken in 24 hours. So that is all day efficiency, and the value is in between 50 to 70% in case of distribution transformers. Let's move on to the next question, question number 23. The strongest diamagnetic material is. The answer for this question is option B. Why? Because no other options are given. Actually, the perfect diamagnetic material is a superconductor. A superconductor can be considered as a perfect diamagnetic material, and a diamagnetic material means it is repelled by a magnetic field, whereas para and ferromagnetic materials means they are being little bit attracted by the magnetic field. Okay, so let's move on to the next question, question number 24. The magnitude of torque developed by a three-phase induction motor depends upon. So before going into that equation, the options, let's go through the equation of a torque developed in an induction motor. Three-phase induction motor torque is directly proportional to phi into I2 into cos theta 2, where phi is the flux responsible for producing the induced EMF, then I2 is the rotor current, and power factor cos theta 2. Okay, when we are considering all these things, we can say this flux is actually proportional to the stator voltage, and the stator voltage is actually proportional to the rotor EMF. So the answer for this question is option A, rotor current is there, okay, rotor power factor is there, and the third one is actually the rotor EMF. Let's move on to the next question. Question number 25. Rheostat method of speed control of an induction motor is used. So this rheostatic method is mainly used for slip ring induction motor. Answer for this question is option B. Why? Because only the external resistance can be connected in the case of slip ring induction motors. In case of squirrel cage induction motors, the rotor is already closed using end rings. So any external circuit cannot be connected in the case of a squirrel cage induction motor. So slip ring induction motors, for slip ring induction motor, external resistance can be connected, and this speed control method is used for slip ring induction motor. So thank you everyone for listening. Hope you understood. Stay tuned.